Hello and welcome to CSC 456. This is the final project submission for real-time networking. We were asked to implement networking for Omega Race game. Also, we have used the data-driven approach to make this game work with the data, work according to the data, not uh, the other way around. So we have used the client-server model to implement networking in the game. In this system, one system acts as a client, the other as server. We have all the processing of the physics carrying out on the server side, not on the nothing being calculated as far as the physics is concerned on the client side. So all the data, all the key inputs are sent from the client to the server. All the physics is being done on the server side, and then the result is sent to the client to update the position or the other values. We are also we have also created a lobby system in this game, which helps us in discovering the client and server within the network, and also to establish a connection between them. We have automatic detection of client and server that are running on the network. We haven't hard coded any kind of IP on the client side or server side. Whenever a server and client are running on the network, they automatically detect each other, sends discovery request, and receive the discovery response, and establish the connection using the lobby. The lobby also helps us in setting up of server and the client on their respective sides. We'll run the game first on the single machine, and then on two different machines. So this is the server side of the game, and this is the client side of the game. On the server and client side, we have the game starting with the load screen. When we press the key on the server side, we get into the lobby, and also pressing the same gets us into the lobby screen for the client. Pressing the H key on the server will take us to the will start hosting the game on the network, and is currently in the lobby state awaiting for any kind of connection. Pressing the J key will try to attempt to connect to the server, and if it finds the server running the application on the port, it tries to connect and establish connection. Pressing the pressing the spacebar key on the server side changes the game state to play, which sends a game state message to the client, and also changes the game state on the client side. On the client side, we do not have any kind of sprites, any kind of physical body for the objects. We just have the sprites on the client side, but on the server side we have actual physical bodies that interact with other objects. We are trying to replicate everything that is going on the server side. We are sending the player update messages to the client to update the location of the ships. So when I press the key on the server side, I have the movement of ship 1, I have the collision detection with the fence, I have the rotation of the ship, which is being replicated on the client side. I have ship to ship collision. So when we have a collision, and when we want an audio event on the server side, we are sending it to a non-networked game manager using the input and output queues. But also we are creating a sound message which is being sent across to the client, so that it can play the sound. So we do not automatically play sound on the client side also. Firing a missile, we have collision detection on the server side, but we are trying to replicate on the client side. So we send a destroy message for the first. We send a fire missile message to the client, which fires the missile. Then we send a destroy message when the missile is destroyed on the server, and with that we also send a message to play the sound to the client. We also send to do the explosion message to the client. Now if we will play the game in 3 loops, we have reduced the life, kills, death values and player score values for the client and server, so that we can reach the game over state early. You can see we have missile colliding with the ship, we have its missile deletion, we have um, explosion effect, we have sound with the missile. Moving the ship 2 on the client side replicates the same for the server side. We have the same effect with the sprites. You can see even from the client side we are working the same way. On the server side, whenever a score is updated, we are sending a player update message, score update message to the client, so that there can be no cheating from the client side. Winning the game or losing 2 lives changes the game state to game over state, and will send a game state message to the client to change its state. Also, when we are sending the message that which player wins to the client, so that it can replicate the same win screen. Pressing the space key on the client will get us into the lobby state, and on the server will take us to the lobby state, and when we press the space key will come to the play state again. We have the same movement of the ships now with the client side. When we try to win, we have the same game over screen, we have the same loop going on from game over to the lobby, and from lobby to the another state. So now also we forgot to mention the laying up of mines. We are sending the message to lay mines and also to delete the mines with the explosion event and the sound. Same is the case with the client side. So now to explain how the game is working, we have data messages both on the client and server side. These are the messages we are going to derive from the data messages. We have score update messages, we are updating the score for the player. We have kill, death, life score, we are sending across to the client so that there can be no cheating on the other side. We have a missile destroy message. We are finding the ID for the missile and destroying the missile. We are destroying the mines by finding the ID. We have a player input message. Whenever we take input key either on the client or the server side, we fill the message and send across to each other. But from the server side, we are not sending any kind of player input message, we just send a player update message for the client. We have a fence hit message. Whenever a fence is hit, we have its animation going on the client side. We have a sound message. We are sending the enum for the sound event, so when it receives on the client side, it plays the same sound. We're sending the game state message from the server side to the client whenever there is a change in the state of the game. We have a player update message which is received from the server to the client, which is sent from the server to the client. These are the new locations, angles for the client ship or the ships on the client side. That's all for the game data messages. For the lobby, The lobby is the location where we are setting up our server and the clients. It's a configuration file for the client and the server that helps in connecting. The server is set to incoming the discovery request, and the client is set to incoming to receive the discovery response. When the first time we set up the client, it tries to if the connection is 0, it tries to connect. When the server is set up, it waits for a discovery request. The client tries to discover any kind of server running the game on this port within the network, no hard-coded IPs. So when it finds a server, it connects automatically, and then after that it tries to run through the loop for receiving data messages. Now we have an input queue on the client and the server side. And we have the output queue for the client and the server side. So we are using only one queue for each, one queue for each. Starting with the game, whenever a key is pressed on the server side, we create a input message. We check whether it's local or whether it's networked. If it's local, it's added to the output queue. Then the receive message is processed. If it's a player input queue, we carry out the check the ID of the player that has been for which the key has been pressed. We rotate or move, and we fire the missile. Also, after doing this, we are whenever this player is moved and rotated in every loop, we are sending in every update we are sending a message to the client with the new location coordinates for the position of the players. So this is the player update message that we are sending to the client. So whenever a key is pressed on the server side, we move the player on the player 1 on the server, and then this update automatically sends the updated location for player 1 and 2, adding it to the queue. The input queue receives the message, it checks the message was networked, it sends it to the client, checks what type of message was that, then it fulfills it into the message as it was a player update message, and then sends it across. Regarding for the client side, whenever a key is pressed, it's added to the input queue as an input message. It's sent to the server as an input message, which when is received follows the same cycle. When we're receiving any kind of message on the server side, we add it to the output queue. We receive the message, we check the message was a player update message that was from the server player, that was the input message from the client side. Then we process it, it was a player 2, and we process the message and then send the updated location, position, angle, and missile fire and that values to the client. For the sound, we are sending the sound message whenever a sound is played on the server side. So let's say we are playing a sound on the missile, so we send on hit we play a sound, so we are sending it both locally and networked. So we create a sound message, fill it with the enum for the sound, and then send it locally. If it's local, it's going to the input queue, output queue, receive message, and play the sound. Also for the client side, we add it to the input queue, it goes into the send message to client, and the sound message is sent to the client, which when on receiving on the other side, adds it to the output queue, checks the message. If it's a sound message, it plays the sound. We're sending across the score for the client and the server. So on the server side it's automatically update, but on the client side we are sending the score, player killed message and score update to the client. It will come here, score update, and send it to the client, which when on receiving processes and updates the score, and similar is for the process kit. For the collision detection, we have, when a missile is destroyed, we set it as true, get the ID and send it across to the client as a missile destroyed message, which on receiving works the same way. Processes finds the missile and destroys the missile by ID. Regarding the game state message, whenever state is changed in the server side, we are sending the game state message locally first, because we have to make it data driven on both the sides. So we create a local message, add it to input queue, adds it to output queue, receives message, and it processes the game state in whatever the state we are. So process the game state and set the state. On the other side, if we are sending a message to the networked client, we are so here is the the game state message, send networked, add to the input queue, checks, sends it to the client. It's a game state message. On receiving, adds it to its output queue, is a game state message. The game state message is received, it's processed, and the output queue is set. We have this debug showing here, which says that we are entering which state. So it says from the lobby you entered play, game over, then again to lobby, then play, game over, lobby, play, game over, as it was required. We'll just that's all we were required to show in the final project for the Omega race, implementing networking and data driven. So also to show the lobby, we have when a space bar is press is key, we enter to the play state from the lobby. Lobby helps us in setting up of the server. This is the lobby draw, and this is the update loop, waiting for the discovery request in the first time, and the next time when we press the key, we have to load the level with the sprites, because after the level has been played and the game over screen, we are cleaning up the sprites and objects. That's all for the final project video submission. Also, we'll try to show this across the screen. So now I'll try to run this system as a client, and we have another system set up that acts as a server. So I'll turn it off, and now this will act as a client, and I'll run the system next system as a server. So I have a server up and running on another system, and this is the client here. I am hosting the game on the server side. Pressing J connects to the server. You see, I am not hard coding any kind of IP. So now I press space key and I get into the game. So if I am not pressing any kind of key on this laptop, on this system, and I am moving the ship on another system, I have muted the voice on another system, so you can see that the sound is being played on the client side. So that's all for the final project, and I hope I have completed all the requirements for the final project. Thank you.